Today's video is lesson 2 of Unit 9. We'll be covering pages 252 to 255. You want to have your calculator and a highlighter. I'm also going to use 2 different colored pens sometimes. So first we want to just kind of sketch 4 different types of functions. A quadratic function, we know is a parabola. It look like this, or it could look like this. Concave up, concave down, and a quadratic function is both increasing and decreasing. A cubic function, let's say an increasing cubic, might look something like this. Or we could have a decreasing cubic. Or we can have both, right? So it could be strictly increasing, strictly decreasing, or both increasing and decreasing. An exponential function this is strictly increasing, that is growth. Or we could have a strictly decreasing. And a log function, this would be a strictly increasing. Or our log function may look like this, in which it's strictly decreasing. The next part, draw and describe the graph of each model that best fits each of the set of data. If we draw this, this looks to match a log function. This cubic. The next one, quadratic. And the last one, this looks like an exponential. On page 253 here, we have some more examples of scatter plots representing our different curves. Right? Some data can be better approximated by a curve instead of a linear function. So we have an exponential, log, quadratic, and cubic. And on the calculator, number 5, when we press Stat Calc, right? 5 is for quadratic, 6 is for cubic, 9 is for log, and 0 is exponential. These are the 4 we'll be using. So what we're going to do is we're going to put data in our L1 and L2, view the scatter plot, and then decide what is the model of best fit. Right? And we just have to use our best judgment in choosing the function family to model our given set of data. So the steps for keying in and showing a scatter plot are up the top here. So following these steps, we key the 2 sets of data into L1 and L2 by pressing Stat Edit. So I press Stat, and then Edit is number 1. Now I already put the data in, so that it wouldn't take the time on the video to do that. You're more than welcome to pause the video and put the data in L1 and L2. We want to turn the stat plot 1 on by doing second y equals. So I'm coming back to the home screen, second y equals. It's off right now. I press enter and then enter again. It's now on. Then we do a zoom 9 to look at the scatter plot and note its shape. And zoom 9. There's the scatter plot. Well, it looks like it may be a little quadratic. Right? I'm going to say it's quadratic. Not the best fit quadratic, but we'll call it quadratic. And we stat calc. Number 5 is for quadratic. Now, we're going to, under the store regression equation, we're going to have it store in y equals. So under store regression equation, we press bars. We want y bars, so arrow over 1. It's on function. Press enter. And we want to store it in y1. Press enter. And enter, enter. So it says to use an appropriate function family to produce a reasonable model. Here we have hours slept and SAT scores. We'll round to 3 decimal places. Y equals negative 27.221 x squared plus 460.120 x minus 152.770. What is the perfect amount of sleep to get before the SATs? If I press graph, it fills in with our regression curve, our quadratic function, and we want the maximum here. So we'll have the calculator calculate the max. Second trace, maximum is number 4. We have to be, it says left bound, so we have to be to the left of the top of the hill, which we are. You just press enter, and then right bound, need to move the cursor so that it's to the right of the top of the hill. So if I'm rounding to, I'm going to round to nearest 100, 8.45. Calculate the score you are predicted to get if you get 5 hours of sleep. I'm going to look at the table of values. That'd be easiest. Second graph, so an input of 5 hours. As an output of 1467. The average SAT score is about 1500 according to the model. What amount of sleep predicts this score? So in Y2, we'll put 1500. So you already put our equation in y1 for us. Now 1500 and second trace number 5. So 6.6 hours of sleep. Oh, sorry, I didn't press enter yet. There we go. 5.17. And second trace, number 4 again, or 5 again. Enter, enter, but for the guess, we got to move it closer to the other intersection point. $11.72 approximately. Okay, so approximately 5 hours and 12 hours. Our next example shows the concentration of a drug in a patient's bloodstream T hours after it was administered. Find a cubic model to fit this data. Okay, so we don't have to look at the scatter plot. It's telling us to use cubic. Stat, edit, arrow up to L2, press clear, enter, up to the heading of L1, clear, enter, and now putting in this data. .52, 2.5, and 3. Double check. Looks good. This is cubic. Stat, calc, cubic is number 6. We'll store the regression equation in. So we need to refer back to the top. Bars. So I'm pressing bars. And then arrow over to y bars. And it's on one function, so press enter. We want y1, press enter. And enter through to calculate. I'm going to round to thousandths. So this is, time is t, and concentration. So I'll do this. So I'll say C of t is equal to 0.012 t to the third plus negative 0.082 t squared plus 0.164 t plus 0.097. And instead of this plus negative, I would have just really put a subtraction. So there's our cubic model. One was the concentration of 0.1825. That's our concentration. Go to y equals. And clear out the 1500 from before and put in 0.1825. And my scatter plot is still on, so I'll just do a zoom 9. Never changed it from before. Here's our nice cubic. second trace, number 5. Let's do a quick sketch of this. We got something like this. .369. And the other point, enter. Move the cursor closer to the other point of intersection. 0.814, comma. So at approximately 0.814 hours and 2.369. Now, example number 3. About a year ago, Joey watched an online video of a band and noticed that it had been viewed only 843 times. 1 month later, he noticed the band's video had 1,708 views. Joey made a table below to keep the track of the cumulative number of views the video was getting online. Write a regression equation that best models this data. Okay, so to save time, I've got the data in L1 and L2 already. All right, there it is. Notice that there was he forgot to record for the second month, so you cannot put the number 2 in and leave L2 blank. It won't work. And you certainly don't want to put 0 in because there were not 0 views during the second month. So you just leave the second month out. Take that out. Alright, so I need my stat plot on. So second y equals, it's on. Zoom 9. That's what it looks like. This looks exponential to me. So we will stat calc. Exponential is 0. And we will store the regression equation in. So vars, y vars, function enter, y1 enter. Rounding to the nearest hundredth. So we said this was exponential. It's something like that. I'm going to put it down here. So v of t, views, in time is equal to 836.47 times 2.05 to the t. As shown in the table, Joey forgot to record the number of views after the second month. Use the equation from part A to estimate the number of full views of the online video. Well, it says to use this, so we'll do that. It would be easy if I just looked at the table of values because we had stored the function in y1. close. So 3,515. Okay, we'll stop there. We're already 20 minutes in with this video. And we'll pick up here tomorrow. Thank you.